For this tutorial, we will enable Visual Components connectivity feature. To enable the feature, go to File, Options, Add-on, and use the toggle switch to enable connectivity. Then click OK below and restart the application. For the robot controller, we will use simulation mode in DENSO WINCAPS 3 offline programming software. Any information on where to acquire any additional software components will be included in the video description. We are in the Program tab and we have created a layout to test driving robot joints using connectivity to DENSO robot controllers. The layout includes a SCARA robot LPH060 and an articulated robot VLA6022 from the DENSO collection in eCatalog. The robots are packaging mobile phones. First, the SCARA robot waits for a sensor signal indicating that the phone box is in the correct position, stops the conveyor, and then waits for another sensor signal indicating that a phone is available. Then the robot picks up one phone and places it in the package. In the end of the line, the articulated robot waits for a sensor signal indicating that a larger transport box has arrived to the correct position, stops the conveyor, and then waits for another signal indicating that a bundle of 4 phone packages is available. After that, the robot picks up the 4 phone packages in one motion and places them into the transport box. All motion statements are set to use a base that is located in the robot's origin. Also, all motion statements are set to use a tool with no offset. Let's open the robot signals editor and examine the signals connected to the robots. For both of the robots, the output signal number 128 has been configured for the grasping and releasing action. In the SCARA robot, the next output signal number 129 is connected to the power on signal of a conveyor. Then, there are 2 Boolean sensor signals connected to input signals 130 and 131. For the articulated robot, the output signal 129 is controlling the gripper. Output signals 130 and 131 are connected to the power on signals of both conveyors. Input signal 132 is connected to a Boolean sensor signal, and input signal 133 is connected to the bundle ready signal of the bundler point component. Let's then translate the robot programs to the robot controller's native language. Select the SCARA robot. From Translators, click Post-Process, find DENSO, and choose Download. Select a file location for the post-processed program, rename it, and save. Close the File Explorer. Download the program for also the articulated robot. We can now open the .bcs files in a text editor and examine the post-processed robot programs. We can see that all of the subsequences, main, pick, and place, were written into one file. Coordinates of all motion points are defined here in the beginning. Next, disable the robot executors in Visual Components. Go to the component properties of the robots and unselect Is Enabled from the Executor tab. After this, the robot program in Visual Components is no longer executed. Let's then start the WINCAPS 3 offline programming software. Log in and create a new project from the File menu. First, create a project for the SCARA robot. Select robot type manually. Name the project as RC8 project and save it in the default location in Documents folder. The robot model is found from folder RC8, family LPH, and with name LPH060. Use the default settings for all steps. We can now view the robot by selecting Arm View from View menu. Then, start another instance of WINCAPS 3 and create a project for the articulated robot. Select robot type manually, name the project as RC9 project, and save it in the default location. The robot model is found from folder RC9, family VL, and with name VLA6022. Use the default settings for all steps. And select Arm View from the View menu. Let's start configuring the projects by importing the post-processed robot program for the SCARA robot. We can import the program from a project menu by choosing Add Existing File. Find the file location where the post-processed programs were saved and import the program for the SCARA. The program now appears in the program list. Open the program in WINCAPS 3 by double-clicking it. Then, we need to set the robot controller's speed to full before running the program on the robot controller. Navigate to ARM operation panel from View menu, ARM operation, and set the speed from 10% to 100%. Then change to the other instance of WINCAPS 3, go to Project, add existing file, find the post-processed program for the articulated robot, import it, and open it from the program list. Go to the ARM operation panel and set the speed from 10% to 100 for also this robot. Next, we will add a server and connect visual components to the RC9 controller used by the VLA6022 robot. In Connectivity tab, choose DENSO Robot from the Connectivity Configuration panel and click Add Server. Choose RC9 for the robot controller version, use local connection, and find the RCPJ file of our RC9 project. Test connection, verify that the connection was successful, and press Apply. Let's then add another server and connect visual components to the RC8 controller used by the LPH060 robot. With an RC8 connection, we need to start a program called bCap Listener. This step is required only for RC8 connections. Find the executable file for bCap Listener from the installation location of ORIN2. You could pause this video now to locate the program. Start the bCap Listener.exe by double-clicking it. A window opens. Minimize but don't close it. Go back to Visual Components, find the file path for the project file, test connection, verify that it was successful, and press Apply. Let's then connect the variables starting from simulation to server variables. Enable connections to both servers. Open the variable pairing editor by selecting the variable group Simulation to Server of the first server and click Add Variables. Filter the variables so that only signal maps are shown in the list. We can now find the signal maps of the robots more easily. For VLA6022, we have signals connected to the input ports 132 and 133. Find these signals from both sides and connect them. Let's then select the simulation to server variables of the second server. We can now connect the I/O signals of the LPH060 robot. Let's minimize the inputs for the articulated robot and find the input signal map for the SCARA robot. For this robot, we have signals connected to inputs 130 and 131. Find the signals and connect them with the respective server variables. Next, we will connect the server to simulation variables, starting from robot output signals. Click the server to simulation variable group of the second server, minimize the list for input signals, and expand the list of output signals for the LPH060 robot. We have signals connected to the output signals 128 and 129. Find the corresponding variables from the server side and connect the variables. Next, select the server to simulation variables of the first server. Scroll up and minimize the output signals of the LPH060. From the VLA6022's output signals, connect signals from 128 to 131 with the respective I/O ports in the server side. Then, let's connect the joint values. Change the filtering from signal maps to degrees of freedom objects. Scroll up the list of server variables and expand the list with the robot arm's name. Find the corresponding joint values from the robot controller behavior of the component. Expand the hierarchies for all joint objects and connect the server variables with the value attribute for each joint. Then, let's connect the joint values for the SCARA robot. Click on the server to simulation variables of the second server and find the joint objects for the LPH060 robot. Connect the value attribute of each joint with the corresponding joint variable in the server side. close the variable pairing editor. Let's next rearrange the windows to show the WINCAPS 3 instances and visual components side by side. Unpin the panels in visual components to make more space. We can now test the connection for the joint values. Run the simulation in visual components, go to WINCAPS 3 and chock the robot's joints using the sliders in arm operation. We can see that both of the robots in visual components follow the joint positions successfully. Reset the simulation. Next, we will run the robot programs in the robot controller. Enable the simulation mode for the LPH060 by pressing the simulation mode button. Select the program and run it by pressing the play button. Choose Program Run mode continuously, so the program will repeat. The program drives the robot into the first motion point and goes to standby mode while waiting for an input signal. Then go to the VLA 6022 project. Enable simulation mode. Select the program. Press play and choose Run mode continuously. Verify that also this robot is driven into the first motion point and the program is in standby mode. As a final touch, let's open the connectivity configuration panel and toggle the RC8 connection off and back on. This is required because we changed the controller into simulation mode after connecting for the first time. Finally, we can run the simulation with robot joints driven by the robot controllers. Run the simulation in visual components and watch as the bones are packaged.